Hello students, in this video I will be going over two examples with you guys where I will be solving for the roots of polynomial equations. So when I say we're going to be solving polynomial equations or solving for the roots of polynomial equation, understand that roots mean the same thing under any circumstance, right? When we were solving for roots for quadratic equation, we were solving for the zeros or the x-intercepts. Those are all synonyms. So that's what we're doing here. So rather than this being a quadratic equation, we're solving for the roots of this polynomial. For this video, okay, the polynomials that we are going to be working with will have quadratic forms embedded in it. What do I mean by this? Well, even though this is an 8th degree polynomial, this is actually a quadratic equation in disguise. How so? Well, this, whoops, I did not mean to erase that. This is an 8th degree polynomial, okay? And however, I also recognize that this is an even degree polynomial. Any even degree polynomial is actually a perfect square. Why is that? Well, let's say we have x to the 6th, let's say, right? X to the 6th is x to the 3rd times x to the 3rd. That is a perfect square. X to the 12th, that's x to the 6th times x to the 6th. X to the 8th, that's x to the 4th times x to the 4th. That is indeed a perfect square. So that leading term there, okay, is a perfect square. How do I make it look more like a quadratic equation then? What I'm going to do, and this is actually an actual algebraic trick, and this is used often when whenever we're trying to solve equations that look really foreign to us. And what we try to do is rewrite the equation into a format that is more familiar to us. So how am I going to rewrite this? I'm going to call u equal to x to the 4th. If I make u equal to x to the 4th, then the entire equation will transform into u to the 4th, or u squared, minus 25u plus 144 equal to 0. And at this point right now, this looks clearer that this is indeed a quadratic equation. And this is something that's factorable. And what will this factor into? This will factor into well, I need two numbers that multiply to 144, but at the same time add to negative 25. So the numbers that come to my mind is 16 and 9, right? So it's u minus 16 and u minus 9 equal to 0. So what are going to be the roots of this equation? So u happens to be 16 or happens to be 9. But wait a minute. We're not solving for u, we're solving for x. Isn't that right? So if we're solving for x and we need to, and I'm going to try to factor this entire thing out, this whole thing then becomes x to the 4th minus 16 and x to the 4th minus 9. Right? Don't forget, that's what the original equation was. We manipulated the situation to make it look like a quadratic equation. And right now, we can continue further with that process, okay, and factor even further. So what is that then? So if I have x to the 4th minus 16, okay, this is actually a difference of squares. This will turn into x squared minus 4, x squared plus 4. And then I have x squared minus 3, and x squared plus 3 is equal to 0. I get to this stage, I need to solve for all roots. So looking at this further factors into, when I say this, I mean x squared minus 4. That further factors into x plus 2, x minus 2. Can I factor x squared plus 4 any further? No, I cannot. So this is x squared plus 4. Can I factor x squared minus 3? Technically I can, because that is still a difference of squares. This is x minus radical 3 and x plus radical 3. What about x squared plus 3? I can't factor that any further, so it's just x squared plus 3 equal to 0. So what are the values of all the roots now that it's factored out entirely? Well, x will equal to -2, +2. That's for these two, right? And then I will have x squared plus 4. Well, I know that if x squared is equal to -4, then therefore x will equal to plus or minus 2i, right? Remember, the instruction says to find all roots. It doesn't say find all real roots. It says find all roots. So therefore, my answers, okay, will be positive 2i and negative 2i. And then I have positive radical 3 and negative radical 3. And I will have plus or minus radical 3i and negative radical 3i. Do you have to list it out all like this? No, you can certainly write it like this. Plus or minus 2, plus or minus 2i, plus or minus radical 3i, plus or minus radical 3. Okay? So you can write it in that succinct manner as well. Whoops. Did not mean to do that. So those are my answers. Okay, let's take a look at another one. All right, I have x to the 6th minus 16x to the 4th plus 64x squared. So what I have right now, I see that there's a GCF, right, immediately. So I'm going to factor that out. So I have x squared, x to the 4th minus 16x squared plus 64 equal to 0. If you recognize what to do, okay, you don't need to use a dummy variable, but if you don't, right, I encourage you to. You don't have to use the letter u. You can use the letter a if you'd like, right? So let's say if a is equal to x squared, then this whole thing turns into a squared minus 16a plus 64 equal to 0. And this will further factor into a minus 8, a minus 8. But remember, a is equal to x squared, so x squared minus 8, x squared minus 8. I can factor this even further. So now I have x squared times x plus radical 8, x minus radical 8. And then x plus radical 8, and x minus radical 8. So looking at this, what are my roots? My roots are x is equal to 0, plus or minus radical 8. I only have 3 sets of roots. There you go.